Hello, in this lecture we will find out the radius of the biggest circle. In the drawing we have four circles, three circles are located inside the biggest circle. We note that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, the radius of the smallest circle is equal to 1 unit, and we want to find out the radius of the biggest circle. Okay, so first of all, I will present to you two theorems that actually is about the two types of tangency between two circles. When two circles are touching each other, there are two types, two ways that they can touch each other. The first way, it is actually the internal lunge. Those two circles are touching each other at this point S, and the center of the small circle is at point M, the center of the big circle is at point O, the radius of the small circle is small r, and the radius of the big circle is equal to capital R. And actually the distance between the centers OM will be equal, as you can see from the drawing, OM equals to OS minus MS. OM equals to OS minus MS, but OS equals to capital R. SM equals to small r, so therefore MO that equals to SMS will be equal to capital R minus small r. So whenever you have two circles that are touching each other internally, they are tangent to each other internally, then the distance between their centers will be equal to the difference between the lengths of their radiuses. That is to say, in this case it will be equal to capital R minus small r. Because as you can see here, MO equals to capital R minus small r. Capital R minus small r. Okay, and the second type of tangency between two circles, so this type of tangency is defined as internal lunge, and the second type of tangency between two circles is the external lunge. External lunge is when the two circles are touching each other externally. Those two circles are touching each other at point S externally. And as you can see here, OM, the distance between their centers OM equals to capital R plus small r. So in conclusion, we can summarize and say that when two circles are touching each other, there are two types of interaction between the two circles when they are touching each other at one point. The first type is the internal lunge. When they are touching each other at one point internally, then the distance between their circles, the distance between their centers will be equal to the difference between the lengths of their radiuses. In this case is OM equals to capital R minus small r, and when the circles are touching each other externally, like in this drawing, then the distance between their centers will be equal to the sum of the lengths of their reducers. That is to say, in this case, it will be equal to capital R plus small r. So OM equals to capital R plus small r. Okay? So now we will define the center of this circle as point A. We know that the radius of this circle is equal to 4 units. We will define the center of this circle as point B. The radius of this circle equals to 9 units. And we will define the center of the smallest circle as point C. The radius of the smallest circle is equal to 1 unit. Here we have 3 points of tangency between this straight line and the 3 circles. The first point of tangency is at this point. We define the point of tangency as point D. I write it down that D is the point of tangency. We will define the touching point or the point of tangency of this straight line with this circle as point E. So E is the point of tangency. You can write here E, D are the point of tangency, and we will define the point of tangency of the smallest circle with the straight line as point F. So points F, D and E are the points of tangency of the straight line with those 3 circles. We will join points A and D together by a straight line. Line segment AD is the radius of this circle. Why? Because it starts from the center of the circle, that is to say from point A, and ends at point D, that is a point of this circle itself. Therefore, AD is the radius of this circle. That is to say, it equals to 4 units. We will join points B and E together by a straight line, and BE is the radius of this circle because of the fact that it starts from point B and ends at point, it starts from point B. Line segment BE starts from point B, that is the center of the circle, and ends at point E, that is a point on this circle itself. Therefore, BE is the center, and BE is the radius of this circle, that is to say, it equals to 9 units. Okay, so I'll write here that line segment BE is the radius of this circle and it equals to 9 units. Likewise, CF will join point C and F together by a straight line. Again, CF is the radius of this circle. So CF equals to 1 unit. In the next step, I will present to you a new rule. It will be called rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here we have the radius AD is drawn to the point of tangency, that is to say it is drawn to point D. D is the point of tangency. Therefore, according to rule number 1, the tangent AD will be perpendicular to the radius AD. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? Likewise, here we have the radius BE of this circle that is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency. E is the point of tendency. Therefore, the tangent FD will be perpendicular to the radius BE. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius CF is drawn to the point of tendency, that is to say it is drawn to point F, that is the point of tendency. We note here that F is the point of tendency of tangent DF with the circle. Therefore, because of the fact that the radius CF is drawn to the point of tendency, therefore the tangent DF will be perpendicular to the radius CF. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, we will define the center of the biggest circle. This point is point O. Again, point O is the center of the biggest circle, this circle, and we will define the radius of the biggest circle, the radius that we are looking for, as capital R. I write here that capital R is equal to the radius of the biggest circle. That is the variable that we are looking for. And in the next step, we will draw perpendicular from point A to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point A and BE as P. We will focus on quadrilateral ADEP. In quadrilateral ADEP, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle ADP. Plus the size of angle ADP. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Again, the sum of the 4 angles in quadrilateral ADEP must be equal to 360 degrees, that is to say 270 degrees, that is the sum of the 3 right angles plus angle ADP must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that the size of angle ADP equals to 360 degrees minus 270 degrees is 90 degrees. So we found that angle ADP is a right angle, it equals to 90 degrees. So this angle equals to 90 degrees. So actually quadrilateral ADEP has 4 right angles. Any quadrilateral that has 4 right angles must be a rectangle. So quadrilateral ADEP is a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say AD equals to PE. AD equals to PE in rectangle ADEP. AD equals to PE. But AD equals to 4 units. It is the radius of this circle. So I can write here that AD equals to 4 units. And from this equation 4 equals to AD equals to PE, we will conclude that DE also equals to 4 units. PE equals to 4 units. Actually, here in quadrilateral or in rectangle ADPE, the opposite sides are equal to each other. It means that AD equals to PE. AD equals to PE, but we know that AD equals to 4 units. So from this equation, 4 equals to AD equals to PE, we will conclude that PE equals to 4 units also. So here PE equals to 4 units. In the next step, we will draw perpendicular from point O to DE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point O and DE as M. So here in quadrilateral AD, so we will define also the intersection point. We define the intersection point between AP and OM, this point, as point S. So actually, in quadrilateral ASDM, we have 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus angle ASM, 270 degrees plus angle ASM. In total, the sum of those 4 angles must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we'll get that angle ASM is equal to 90 degrees. Angle ASM equal to 90 degrees. OM is the perpendicular from point O. OM is perpendicular from point O, so OM is perpendicular. It is absolutely a straight line. OM is a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then at point S, on this side, the sum of the angles must be equal to 180 degrees. Which angles we have at point S? We have here 90 degrees plus angle OSA. 90 degrees plus angle OSA. In total, the sum of those two angles must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we will get that angle OSA equals to 90 degrees. Angle OSA equals to 90 degrees. This angle equals to 90 degrees. In quadrilateral SPME, we have three right angles, 1, 2, 3. Again, the sum of three right angles is 270 degrees, plus the size of angle PSM, this angle, in total, the sum of those four angles must be equal to 360 degrees. We'll subtract 270 degrees from this equation, and we will get that the size of angle PSM equals to 90 degrees. So this angle PSM is a right angle, it equals to 90 degrees. So here, quadrilateral SPME has four right angles, therefore quadrilateral SPME is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. Here, the opposite sides of this rectangle are equal to each other. That is to say, PE equals to SM. PE equals to SM. But we've already found out that PE equals to 4 units. So from this equation, P4 equals to PE equals to SM, we will conclude that SM also equals to 4 units. Here SM equals to 4 units. What is the value of line segment BP? The value of line segment BP equals to BE minus PE. Again, BE minus PE equals to BP. BP equals to BE minus PE. I'll repeat again. Line segment BP equals to BE minus PE. So BP line segment BP equals to BE. BE equals to 9 units. It is the radius of this circle. Minus PE, we've already found out that PE equals to 4 units. So in conclusion, BP equals to 9 minus 4, that is 5. So we found out that BP equals to 5 units. We can write here that BP equals to 5 units. In the next step, we will join points A and B together by a straight line. What is the length of AB? The length of the straight line AB. AB is the distance between this circle and this circle. AB is the distance between the centers of those two circles, because point A is the center of this circle, that its radius is 4 units. Point B is the center of this circle, that its radius is 9 units. So those two circles have an external launch between them. They are touching each other at this point. Therefore, the distance between two circles that have an external launch between them, like in this case, is equal to the sum of the length of the radiuses. That is to say, it equals to the radius of this circle plus the radius of this circle. The radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units. 4 plus 9 is 13. So the distance of the length of line segment AB equals to 13 units. And triangle ABP is a right triangle, because angle BPA is a right angle. We will implement the Pythagoras theorem on triangle ABP, the right triangle, triangle ABP. Here, the letters P and T is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here the hypotenuse is AB, so the square of the hypotenuse is AB squared. And it equals to the sum of the squares of the perpendiculars, that is to say, it equals to BP squared plus AP squared. I'll repeat again. According to the Pythagoras theorem, in the right triangle, triangle ABP, AB squared equals to BP squared plus AP squared. AB equals to 13, so AB squared is 13 squared. 13 squared is 169. And it equals to BP squared. BP equals to 5 units, so BP squared is 5 squared. 5 squared is 25, plus AP squared. AP is the missing variable, so we will leave it as it is. So in conclusion, we found out that $169 equals to 25 plus AP squared. We subtract 25 from this equation and we get that 169 minus 25 is 144. So 144 equals to AP squared. Here we will take a root out of this equation and we will get that AP equals to the square root of 144. The square root of 144 is 12. So we found out that AP equals to 12 units. We write here that AP equals to 12 units. We have already found out that quadrilateral ADPE is a rectangle. Why? Because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say AP equals to DE. So in rectangle APDE, the opposite sides are equal to each other. That is to say AP equals to DE. AP equals to DE. But we just right now found out that AP equals to 12 units. So from this equation, we will derive that DE also equals to 12 units. Here we will write down that DE equals to, again here in rectangle APDE, AP equals to DE, so DE equals to 12 units. D equals to 12 units. We'll define ME as X. ME equals to X according to our definition. So we can write here that ME equals to X according to our definition. What is the value of DM? DM will be equal to DE minus ME. Again, DE minus ME equals to DM. DM equals to DE minus ME. You can see it easily from the drawing. DM equals to DE minus ME. So DM equals to DE. DE is the radius of this circle, that is to say here DE equals to 12 units. DE equals to 12 units. We found out that D equals to 12 units. And ME equals to X according to our definition. ME equals to X. So in conclusion, we found out that DM equals to 12 minus X. So we can write here that DM equals to 12 minus X. We have already found out that quadrilateral ADMS is a rectangle because of the fact that it has four right angles, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle ASTM, in this rectangle, the opposite sides are equal to each other. That is to say, DM equals to AS, DM equals to AS. Again, in rectangle ASDM, DM equals to AS. But we found out that DM equals to 12 minus x, so we can write here that DM equals to 12 minus x, and from this equation 12 minus x equals to DM equals to AS, we will derive that AS also equals to 12 minus x. AS equals to 12 minus x. So here AS is also equal to 12 minus x. And what is the value of OS? The value of OS you can see it easily from the drawing that OS is equal to OM minus SM. OS equals to OM minus SM. Again, OS equals to OM minus SM. We will define OM as Y. OM is equal to Y according to our definition. OM equals to Y according to our definition. So we can write here that line segment OM is equal to Y according to our definition. So we found out that OS equals to OM minus SM. So OS equals to OM and OM equals to Y according to our definition minus SM. What is the value of SM? The value of SM, you can see here that the value of SM is 4 units. So SM equals to 4. So in conclusion, we found out that OS equals to Y minus 4. OS equals to Y minus 4. Write it here that OS equals to Y minus 4. And what is the value of AO? So maybe I will draw the triangle AOS in a new page. I will find out the value of its sides. We have the hypotenuse AO. So this is the right triangle AOS. Angle OSA equals to 90 degrees. Therefore, triangle AOS is a right angle. What is the value of the hypotenuse AO? Here, A is the center of the circle that its radius is 4 units. O is the center of the biggest circle that its radius is capital R. The biggest circle and this circle have an internal length between them at this point. They are touching each other at this point, and any two circles that have an internal length between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. The length of the radius of the biggest circle is capital R. The length of the radius of this circle is 4 units. And the difference between the lengths of the radiuses is capital R minus 4. So AO equals to R minus 4. Right here, that AO equals to R minus 4. So here we can implement the Pythagoras theorem on the right triangle, the right green triangle, triangle AOS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This will be equation number 1. The square of the hypotenuse is AO, the square of the hypotenuse is AO squared, and it equals to the sum of the squares of the perpendiculars. The sum. So here, according to the Pythagoras theorem, in the right triangle, triangle AOS, by PT, that is Pythagoras theorem, the square of the hypotenuse is AO squared. It equals to the sum of the squares of the perpendiculars. It equals to OS squared plus AS squared. So here AO squared is R minus 4 squared equals to OS squared. OS equals to Y minus 4, so OS squared equals to Y minus 4 squared plus AS squared. AS equals to 12 minus X, so AS squared will be equal to 12 minus X squared. We will open the brackets on both sides of equation number 1, and we will get that according to equation number 1, R minus 4 squared is R squared plus 16 minus 8R, and it equals to Y minus 4 squared. Y minus 4 squared is Y squared plus 16 minus 8y plus 12 minus x squared. 12 minus x squared is 144 plus x squared minus 24x. Here we have 16 on both sides of equation number 1, so 16 will get cancelled. We will add 8r to this equation, equation number 1, and we'll get that r squared equals to 8r minus 8y plus 144 minus 24x plus x squared plus y squared. Here we will subtract x squared and y squared from this equation, equation number 1, and we will get that according to equation number 1, r squared minus x squared minus y squared equals to 8r minus 8y plus 144 minus 24x. Here we will take a common factor 8 out of those two expressions, and we will get that according to equation number 1, r squared minus x squared minus y squared equals 2. So we took 8 as a common factor out of those two expressions, so in the brackets we will have r minus y plus 144 minus 24x. So this is equation number 1. In the next step, we will draw perpendicular from point O to BE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point O to BE as point T. So I will draw the right triangle OBT in a new page in order to clarify the drawing. So we have the right triangle OBT. We have already found out that quadrilateral MOTE, here quadrilateral MOTE has 4 right angles, has 3 right angles, 1, 2, 3. I will repeat again. Quadrilateral OTME has 3 right angles. The sum of 3 right angles is 270 degrees plus angle MOT In total, the sum of those four angles must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we will get that angle MOT is equal to 90 degrees. So this angle equals to 90 degrees. Therefore, quadrilateral MOTE is a rectangle, and we've already found out that ME equals to X according to our definition, OM equals to Y according to our definition. So we know that the opposite sides of rectangle OTME are equal to each other. What does it mean? It means that OM equals to TE. OM equals to TE. But OM equals to Y according to our definition. So from this equation, Y equals to OM equals to TE, we will conclude that TE also equals to Y. So we can write here that TE equals to Y. Likewise, side ME equals to side OT in rectangle OMTE according to the rule that the opposite sides of a rectangle are equal to each other. ME equals to OT. But ME equals to X according to our definition. From this equation, X equals to ME equals to OT, we will derive that OT also equals to X. OT also equals to X. What is the value of BT? We know that BE is the radius of this circle that equals to 9 units. So BE equals to 9 units. Therefore, actually BT, you can see it easily from the drawing, that BT equals to BE minus TE. BT equals to BE minus TE. I repeat again. BT equals to BE minus TE. You can see it easily from the drawing. BT equals to BE minus TE. So BT equals to BE, that is 9 units, minus TE that is Y. So in conclusion, we found out that BT equals to 9 minus Y. You can write here that BT equals to 9 minus Y. What is the value of OB? You should remember that point O is the radius of the biggest, it's the center of the biggest circle, and point B is the center of the circle that its radius is equal to 9 units. The biggest circle and this circle have an internal lunge between them and this point. At this point they are touching each other internally. Therefore, the distance between their centers, that is to say OB, will be equal to the difference between the lengths of their radiuses. The radius of the big circle is equal to capital R. The radius of this circle is equal to 9. Therefore, OB will be equal to R minus 9. That is the difference between the lengths of the radiuses of those two circles, the biggest circle and this circle. So we found out that OB equals to R minus 9. Now we will implement the Pythagoras theorem. on the green right triangle, triangle OBT. So here, in the right triangle, triangle OBT, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, this will be equation number 2, OB squared will be equal to BT squared plus OT squared. I repeat again. In the right green triangle, triangle OBT, according to the Pythagoras theorem, the square of the hypotenuse, that is OB squared, equals to the sum of the squares of the perpendiculars, equals to BT squared plus OT squared. OB equals to R minus 9, so OB squared is R minus 9 squared. And it equals to BT squared. BT is 9 minus 1, so BT squared is 9 minus y squared plus OT squared. OT is x, so OT squared is x squared. In conclusion, we found out that according to equation number 2, R minus 9 squared equals to 9 minus y squared plus x squared. Here we will open the brackets on both sides of equation number 2, and we will get that R minus 9 squared is actually equals to R squared plus 81 minus 18 R equals to 9 minus y squared. 9 minus y squared is 81 plus y squared minus 18y plus x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. In the next step we will add 18r to this equation, equation number 2, and we will get that according to equation number 2, r squared equals to 18r minus 18y plus x squared plus y squared. Here we'll take a common factor of 18 out of those two expressions, and we will get that r squared equals to, so 18 is taken out as a common factor. Inside the brackets we will have r minus y plus x squared plus y squared. We will subtract x squared and y squared from this equation, equation number 2, and we will get that according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. Okay, so this is equation number 2. In the next step, we will draw first of all, we know that the quadrilateral SPME is a rectangle because of the fact that it has 4 right angles, and here we rectangle SPME ME equals to SP, again in rectangle SPME, ME equals to SP, but ME equals to X according to our definition. ME equals to X, so from this equation X equals to ME equals to SP, we conclude that SP also equals to X. SP equals to X, so we can write here that SP equals to X. In the next step, we will draw perpendicular from point C to BE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point C and BE is Q. So in quadrilateral QCEF, we have 3 right angles, 1, 2, 3, and the sum of 3 right angles is 270 degrees, plus the size of angle QCF. In total, the sum of those 4 angles must be equal to 360 degrees. I'll repeat again, in quadrilateral QCEF, the sum of the angles must be equal to 360 degrees, that is to say the sum of 3 angles, that is 270 degrees, plus angle QCF must be equal to 360 degrees. We'll subtract 270 degrees from this equation, and we will get that angle QCF equals to 90 degrees. Angle QCF equals to 90 degrees. So quadrilateral QCEF has 4 right angles, therefore quadrilateral QCEF is a rectangle so we know that quadrilateral QCEF is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE. CF is equal to QE in quadrilateral QCEF. But CF equals to 1 unit because it is the radius of the smallest circle. So for this equation Q equals to CF equals to 1, we will conclude that CF also equal to 1 unit. No. 1 equals to CF equals to QE. From this equation, we will conclude that QE also equals to 1 unit. QE also equals to 1 unit. So we can write here that QE equals to 1 unit. In the next step, we will join points B and C together by a straight line. What is the length of BC? B is the center of this circle that its radius is equal to 9 units. C is the center of the smaller circle that its radius is equal to 1 unit. Those two circles have an external length between them, that is to say they are touching each other externally, and therefore the distance between their centers, that is to say BC, will be equal to the sum of the lengths of their radiuses. That is to say it will be equal to 9 plus 1, that is 10. In conclusion, we found out that BC equals to 10 units. So BC equals to 10 units. What is the value of QB? The value of QB is equal, you can see it easily from the drawing, that QB equals to QE. QB or BQ is equal to BE minus QE. Again, QB or BQ is equal to BE minus QE. So that is to say QB equals to BE. BE is the radius of this circle that equals to 9 units. We just right now found out that QE equals to 1 unit. So in conclusion, we found out that QB equals to 9 minus 1, that is 8 units. QB equals to 8 units. So in the right triangle QBC, we will implement the Pythagoras theorem. According to the Pythagoras theorem, in the right triangle QBC, we will implement the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, so the square of the hypotenuse is BC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to QC squared. QC is the missing variable, plus BQ squared. I will repeat again. In the right triangle QBC, according to the Pythagoras theorem, BC squared equals to QC squared plus BQ squared. So here we have already found out that BC equals to 10 and BQ equals to 8. Here BQ, QB equals to 8 units, so BC equals to 10, so BC square is 10 square. 10 square is 100, equals to QC square. QC is the missing variable, so we leave it as it is. QC square plus BQ square. BQ equals to 8, so BQ square is 8 square. 8 square is 64. We will subtract 64 from this equation, and we will get that 100 minus 64 is 36, so QC square equals to 36. Here we will take a root out of this equation, and we will get that QC is equal to the square root of 36, that is actually 6. The square root of 36 is 6. So we found out that QC is equal to 6 units, and we actually found out that QCEF is a rectangle. Here QCEF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, QC is equal to EF QC is equal to EF but we just right now found out that QC equals to 6 units. So from this equation 6 equals to QC equals to EF, we will conclude that EF also equals to 6 units. EF also equals to 6 units. From point C, we will go perpendicular to OM. So this angle will be equal to 90 degrees, this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point C to OM as U. So here, quadrilateral UCMF has 4 right angles, 1, 2, 3, 4. Because of the fact that quadrilateral UCMF has 4 right angles, quadrilateral UCMF is a rectangle, and the opposite sides of a rectangle are equal to each other. First of all, the opposite sides of rectangle UCMF are equal to each other. So MF equals to UC, so MF is equal to UC. But MF equals to x plus 6. From this equation, UC equals to MF equals to x plus 6. We will conclude that UC also equals to x plus 6. UC equals to x plus 6. So here UC equals to x plus 6. This is first thing that we can do, conclude from the fact that UCFM is a rectangle. The second thing that we conclude from it is that CF equals to UM. CF equals to UM. But we know that CF is the radius of the smallest circle, that is to say it equals to 1 unit. So from this equation UM equals to CF equals to 1, we will derive that UM also equals to 1 unit. UM equals to 1 unit. You can write here that UM equals to 1 unit. And what is the value of OU? OU, this line segment OU. OU will be equal to OM minus UM. Again, OU equals to OM minus UM. That is to say, OU equals to OM. OM is equal to Y according to our definition. OM equals to Y according to our definition. And UM equals to 1. We just right now found that UM equals to 1. So in conclusion, we found that OU equals to Y minus 1. What is the value of UC? We have already found out that the value of UC is x plus 6. The value of UC is x plus 6. We join points O and C together by a straight line. What is the value of OC? O is the center of the biggest circle, that its radius is capital R. C is the center of the smallest circle, that its radius is 1 unit. And the biggest circle and the smallest circle have an internal length between them at this point. Whenever you have two circles with an internal length between them, it means that the distance between their centers, that is to say OC, will be equal to the difference between the lengths of their radiuses. The length of the radius of the biggest circle is capital R, the length of the radius of the smallest circle is 1, and the difference between the length is R minus 1. So, in conclusion, we found out that OC equals to R minus 1. I will draw triangle OUC in a new page, and we will implement the Pythagoras theorem on the right triangle, triangle OUC. So here the green right triangle is triangle OUC. We will implement the Pythagoras theorem on this green right triangle, triangle OUC. So here in triangle OUC, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is OC, the square of the hypotenuse is OC squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to OU squared plus UC squared. So according to equation number 3, we will get that OC is R minus 1, so OC squared is R minus 1 squared, and it equals to OU squared. OU is Y minus 1, so OU squared is Y minus 1 squared plus UC squared. UC equals to X plus 6, so UC squared equals to X plus 6 squared. We will open the brackets on both sides of equation number 3, and we will get that R minus 1 squared equals to R squared plus 1 minus 2R, that equals to Y minus 1 squared is Y squared plus 1 minus 2Y plus X plus 6 squared, of course, here. UC squared is X plus 6 squared. So X plus 6 squared is X squared plus 36 plus 12X here we have 1 on both sides of equation number 3, so 1 will get cancelled. We will add 2R to this equation, equation number 3, and we will get that according to equation number 3, R squared equals to 2R minus 2Y plus 36 plus 12X. Here we plus X squared plus Y squared. Here we'll subtract X squared and Y squared from this equation, equation number 3, and we'll get that according to equation number 3, R squared minus X squared minus Y squared equals to here we have 2R minus 2Y, so we take a common factor of 2 out of those two expressions. So inside the brackets we will have R minus Y plus 36 plus 12X. In conclusion, we found that according to equation number 3, R squared minus X squared minus Y squared equals to 2 times R minus Y plus 36 plus 12X. Plus 12X. So we will write down all the 3 equations in a new page, and we will solve those 3 equations. We will find out the values of X, Y, and capital R, that is the value that we are looking for, the radius of the biggest circle. So according to equation number 3, we found out that r squared minus x squared minus y squared equals to 2 times r minus y plus 36 plus 12x. This is equation number 3. Equation number 2, according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y, and equation number 1, according to equation number 1, we found out that r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. In the next step, we will create equation number 4 that states that r squared minus x squared minus y squared according to equation number 1 must be equal to r squared minus x squared minus y squared according to equation number 2. So equation number 4 states that r squared minus x squared minus y squared according to equation number 1, that is actually 8 times r minus y plus 144 minus 24x. So this must be equal to r squared minus x squared minus y squared according to equation number 2, that is actually equals to 18 minus 18 times r minus y. Here we'll subtract 8 times r minus y from this equation, equation number 4, and we'll get that according to equation number 4, (144) minus 24x equals to 10 times r minus y. Here we will divide equation number 4 by 10, and we will get that according to equation number 4, r minus y equals to 144 minus 24x over 10. Here we will divide equation number 4, this side of equation number 4 by 2. We'll divide both the numerator and the denominator by 2, and we'll get that according to equation number 4, r minus y equals to 144 over 2 is 72, and minus 24x over 2 is minus 12x, and 10 over 2 is 5. So in conclusion, we found out that according to equation number 4, r minus y equals to 72 minus 12x over 5. In the next step, we create equation number 5. Equation number 5 states that r squared minus x squared, r squared minus x squared minus y squared according to equation number 2 must be equal to r squared minus x squared minus y squared according to equation number 3. So r squared minus x squared minus y squared according to equation number 2 is 18 times r minus y, and it must be equal to r squared minus x squared minus y squared according to equation number 3, that is actually equals to 2 times r minus y plus 36 plus 12x. Here we will subtract 2 times r minus y from this equation, equation number 5, And we will get that according to equation number 5, it 16 times r minus y equals to 36 plus 12x. Here we will divide the equation number 5 by 16 and we will get that r minus y equals to 36 minus 36 plus 12x over 16. Here we will divide both the numerator and the denominator of this side of equation number 5 by 4, and we will get that r minus y according to equation number 5 is equal to 36 over 4 is 9, 12x over 4 is 3x, 16 over 4 is 4. So in conclusion, we found out that r minus y according to equation number 5 is equal to 9 plus 3x over 4. In the next step, we will create equation number 6 that states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. So equation number 6 states that r minus y according to equation number 4, that is actually equals to 72 minus 12x over 5, must be equal to r minus y according to equation number 5, that is actually equals to 9 plus 3x over 4. Okay, so here we have equation number 6. Here we will multiply equation, we will cross multiply equation number 6, and we will get that according to equation number 6, 72 minus 12x times 4 is equal to 5 times 9 plus 3x. Here we will open the brackets on both sides of equation number 6, and we will get that according to equation number 6, four times 72 is 188. 4 times minus 12x is minus 48x. Five times 9 is 45, and 5 times 3x is 15x. Here we'll subtract 45 from this equation, equation number 6, and we'll get that 288 minus 45 is 243, and here 48x plus 15x is 63x. Here we will divide equation number 6 by 9, and we will get that 63 over 9 is 7. 200 33 over 9 is 36. 243 over 9 is 27. Here we will divide equation number 6 by 7, and we will get that the value of x according to equation number 6 is equal to 27 over 7. According to equation number 5, r minus y is equal to 9 plus 3x over 4. Here we will put the value of x inside equation number 5, x equals to 27 over 7. So according to equation number 5, r minus y is equal to 9 plus 3x, and x equals to 27 over 7, so it equals to 3 times 27 over 7 over 4. So according to equation number 5, r minus y is equal to 9 plus 3 times 27 is 81 over 7, all divided by 4. Here we will multiply 9 by 7, and then we will divide it by 7 in order to have a common factor with 81 over 7. So 9 times 7 is 63. 63 plus 81 over 7 over 4 is equal to r minus y according to equation number 5. (63) plus 81 is 144, and we will move 4 to the denominator, and 4 times 7 is 28. So in conclusion, we found out that r minus y according to equation number 5 is equal to 144 over 28. We will divide both the numerator and the denominator of this number by 4, and we'll get that r minus y according to equation number 5 equals to 144 over 4 is 36, 28 over 4 is 7. So in conclusion, we found out that r minus y according to equation number 5 is equal to 36 over 7. And we have already found out that x equals to 27 over 7. In the next step, we will copy again equation number 2. According to equation number 2, we have already found out that r squared minus x squared minus y squared equals to 18 times r minus y. So here r squared minus y squared is r plus y r minus y. According to the algebraic identity, that r a square minus b square equals to a square minus b square equals to a plus b times a minus b. So it is r square minus y square is r plus y times r minus y minus x squared equals to 18 times r minus y. Here we will add x squared to this equation, equation number 2, and we will get that r plus y times r minus y equals to, so we added x squared to this equation, equation number 2, so it equals to x squared plus 18 times r minus y. We have already found out that x equals to 27 over 7, and r minus y, according to equation number 5, equals to 36 over 7. So we will substitute r minus y and x squared in equation number 2 by the values that we found for them, and we'll get that according to equation number 2, r plus y times r minus y, and r minus y equals to 36 over 7. That equals to x squared. X equals to 27 over 7, so x squared will be equal to 27 over 7 squared plus 18 times r minus y, and r minus y equals to 36 over 7. Here we will multiply this equation, equation number 2, by 7, and we'll get that r plus y times 36 equals to 27 times 27 over 7 plus 18 times 36. Here we'll divide equation number 2 by 9. (36 over 9 is 4, so it is 4 times r plus y equals to 27 over 9 is 3, so it is 3 times 27 over 3 plus 18 over 9 is 2, so it is 2 times 36. 2 times 36 is 72. Here we'll multiply 72 by 7, and then we'll divide it by 7 in order to have a common factor with this expression, and we'll get that 4 times r plus y is equal to 3 times 27 is 81 over 7, and we have 7 times 72. Here 7 times 72 is 504, so we get that 4 times r plus y is equal to 81 plus 504 over 7. 81 plus 504 is 585, so we'll write it down. So according to equation number 2, we found out that 4 times r plus y is equal to 585 over 7. So here we'll divide equation number 2 by 4, and we'll get that according to equation number 2, r plus y is equal to 585 over 4, but 4 times 7 is 28. We have already found out that according to equation number 5, r minus y is equal to 36 over 7. Here we will multiply equation number 5, both the numerator and the denominator of this side of equation number 5 by 4. And we will get that r minus y is equal to 36 times 4 is 144. And 7 times 4 is 28. So we have equation number 2 that states that r plus y is equal to 585 over 28, while according to equation number 5 we found out that r minus y is equal to 144 over 28. Here we will add equation number 2 to equation number 5, and we will get that r plus r is 2r, so 2r, and y plus minus y is 0, and it equals to 585 plus 144 over 828. So 2r is equal to 585 plus 144 is 729 over 28. We will divide this equation by 2, and we will get that r, the radius that we are looking for of the biggest circle, is equal to 729 over 56 units, or in terms of numbers, it equals to 13.018 units. So I'll repeat again. The radius of the biggest circle is equal to either 729 over 56 units, or we can represent it as 13.018 units. Okay, I'll repeat again. The radius of the biggest circle is equal to either 729 over 56 units, or in terms of numbers, it equals to 13.018 units. In the next step, I will summarize the lecture. Actually, we wanted to find out the radius of this biggest circle. Inside this circle we have 3 other small circles. We know that the radius of this circle is 4 units, the radius of this circle is 9 units, and the radius of the smallest circle is 1 unit. And we want to find out the radius of the biggest circle. So here we defined the center of this circle as point A, the center of this circle as point B, and the center of the smallest circle as point C. In the next step, we will define the point of tendency here, point D, we define the point of tendency of the tangent with this circle as point E, and we define the point of tendency of the tangent with the smaller circle as point F. Then we join together points A and D. AD is the radius of this circle, that is to say it equals to 4 units. We join together points B and E by straight line. B is the radius of this circle, that equals to 9 units. We join points C and F together by a straight line. CF is the radius of the smallest circle, that equals to 1 unit. And I actually presented to you two new theorems, that is actually the internal lunge and the external lunge. When you have two circles that are touching each other at one point, then there is two types of tangency between those two circles. The first type is the internal lunge, when the two circles are touching each other internally, that is to say at point S, the two circles are touching each other. Point S is the point of tendency. In this case, the distance between their centers, that is to say MO, is equal to capital R minus R. So this is the internal lunge. So whenever two circles are touching each other internally, then the distance between their centers is equal to the difference between the lengths of their radiuses. In this case, in this specific case, is equals to capital R minus small r. We have also the second type of tangency between two circles. The second type of tangency between two circles is the external lunge. External lunge is when the two circles are touching each other externally, like here. Point S is the point of tendency. Between those two circles, they are touching each other at point S. And the distance between their centers, that is to say MO, equals to capital R plus R, that is to say whenever two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radiuses. That is to say, in this case, it will be equal to capital R plus R. This is the external lunge. Okay? Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here we have the radius AD is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of this tangent with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to the radius AD, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we have here the radius BE is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency of tangent FD with this circle. Therefore, according to rule number 1, the tangent FD will be perpendicular to this radius BE, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, I will not repeat on this small circle, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees for the same reasons. Then, in the next step, from point A, we draw perpendicular to BE. So this angle equals to 90 degrees, this angle equals to 90 degrees. We define the touching point between the perpendicular from point A to BE as point P. Actually, quadrilateral ADEP, this quadrilateral, we have three right angles, 1, 2, 3. The sum of three right angles is 270 degrees. So 270 degrees plus the size of this angle, this is actually angle DAP or PAD. So the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle ADB equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that this angle is a right angle, it equals to 90 degrees. Therefore, quadrilateral ADEP that has four right angles is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AD is equal to PE. In rectangle ADEP and AD equals to PE. But we know that AD equals to 4 units. It is the radius of this circle. So we can write here that AD equals to 4 units. From this equation, 4 equals to AD equals to PE. We will conclude that PE also equals to 4 units. Here, PE equals to 4 units. Likewise, we have quadrilateral ASDM. But before that, from point O, we draw perpendicular to DE. Again, from point O, we draw perpendicular to DE. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point between the perpendicular from point O to DE as M. We focused on quadrilateral ADEP. Quadrilateral ADEP. This quadrilateral ADEP, we have already found out that quadrilateral ADEP is a rectangle, and then we focused on quadrilateral ASDM. This quadrilateral ASDM, in this quadrilateral ASDM, we have three right angles, 1, 2, 3. So the sum of three right angles, that is 270 degrees plus the size of angle ASM, in total they must be equal to 360 degrees. Again, 270 degrees, that is the sum of three right angles plus the size of angle ASM, they must be equal in total to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle ASM equals to 90 degrees. This angle is a right angle, is equals to 90 degrees. Therefore, in quadrilateral ASDM, we have four right angles. In any quadrilateral that has four right angles, it is a rectangle. So, quadrilateral ASDM is a rectangle, and we know that the opposite sides of a rectangle are equal to each other, and here quadrilateral SP, so quadrilateral ASDM is a rectangle, and angle ASM is equal to 90 degrees. OM, from point O we draw perpendicular to DE, so OM is a perpendicular, it must be a straight line. OM is a straight line, And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the straight line OM on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. So which angles we have at point S and this side of the straight line OM? We have 90 degrees plus angle OSA. So according to the rule that I stated, 90 degrees plus angle 90 degrees plus angle OSA. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle OSA is a right angle, it equals to 90 degrees. So this angle OSA is a right angle, therefore triangle AOS is a right angle. So this angle is a right angle, therefore the green triangle ASO is a right triangle. Then we focused on quadrilateral SPME. On quadrilateral SPME, we have three right angles. That is actually 1, 2, 3 right angles, and the sum of three right angles is 270 degrees. So 270 degrees plus the size of this angle, that is actually angle PSM. In total, the sum of those four angles must be equal to 360 degrees. We subtracted 90 degrees from this equation, and we found out that angle PSM, this angle equals to 90 degrees. So quadrilateral SPME has four right angles, therefore quadrilateral SPME is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, PE equals to SM. PE equals to SM. But we have already found out that PE equals to 4 units. From this equation, PE equals to 4 equals to SM, we will conclude that SM also equals to 4 units. So here SM also equals to 4 units. Then we found out the value of line segment BP. What is the value of BP? BP, you can see it easily, that BP equals to BE minus PE. BE minus PE equals to BP. BP equals to BE minus PE, but BE is the radius of this circle that equals to 9 units. We have already found out that PE equals to 4 units, therefore BP equals to 9 minus 4, that is to say 9 minus 4 is 5, so BP equals to 5 units. And then we join points A and B by a straight line. What is the value of line segment AB? A is the center of this circle that its radius is equal to 4 units. B is the center of this circle that its radius is equal to 9 units. Those two circles have an external length between them at this point. That is to say, they are touching each other at this point. Therefore, any two circles that have an external length between them, then the distance between their centers will be equal to the sum of the lengths of their radiuses. The radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the sum of the two radiuses is equal to 4 plus 9. 4 plus 9 is 13. So we found out that AB equals to 13 units, BT is equal to 5 units, so in the right triangle ABP, according to the Pythagoras theorem, AB squared will be equal to AB squared equals to BP squared plus AP squared. In the right triangle ABP, by Pythagoras theorem, AB squared equals to PB squared plus AP squared. AB equals to 13 units, therefore AB squared is 13 squared. 13 squared is 169 plus PB squared. PB equals to 5. So PB squared is 5 squared, 5 squared is 25. AP is the missing variable, so we leave it as it is. So we got that 169 equals to 25 plus AP squared. We subtracted 29 from this equation and we found out that 169 minus 25 is 144. 144 equals to AP squared. We took a root out of this equation and we found out that AP equals to the square root of 144. The square root of 144 is 12. That is to say AP equals to 12 units. Here AP equals to 12 units. Okay? Actually, quadrilateral APDE, actually we have already found out that quadrilateral APDE is a rectangle. This quadrilateral is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say AP equals to DE. In rectangle APDE, AP equals to DE. But we just right now found out that AP equals to 12 units. So from this equation 12 equals to AP equals to DE, we will conclude that DE also equals to 12 units. So here we can write down that DE equals to 12 units. So here we defined ME as X. So here ME equals to X according to our definition. What is the value of DM? What is the value of DM? Here DM equals to DE minus ME. Again, DE minus ME equals to DM. Okay? DM equals to DE minus ME. But DE equals to 12 units. ME equals to X according to our definition. So in conclusion, we found out that DM equals to 12 minus X. Here, DM equals to 12 minus X. But we have already found out that quadrilateral ASDM is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say DM equals to AS. DM equals to AS. But we have already found out that DM equals to 12 minus X. So from this equation DM 12 minus X equals to DM equals to AS. We will conclude that AS equals also to 12 minus X. So here AS equals to 12 minus X. And actually here, because of the fact that quadrilateral SPME is a rectangle and ME equals to X, therefore ME equals to SP. So if ME equals to X, then SP also equals to X. Okay? And then we found out the value of OS. Here OS, what is the value of OS? Here you can see it easily from the drawing that OS equals to OM minus SM. Again, OS equals to OM minus SM. So, and according to our definition, OM equals to Y. So in conclusion, OS will be equal to OM, that is Y, minus SM. But SM equals to 4 units. So in conclusion, we found out that OS equals to Y minus 4. And we have already found out that AES equals to 12 minus X. AES equals to 12 minus X. And OS equals to Y minus 4. AES equals to 12 minus X. What is the value of OA? The value of OA. O is the center of the biggest circle. That its radius is capital R. A is the radius, is the center of this circle, that its radius is equal to 4 units. The biggest circle and this circle has internal notch between them. At this point they are touching, that is to say they are touching each other at this point. Whenever two circles have an internal notch between them, the distance between their centers will be equal to the difference between the lengths of their radii. The radius of the biggest circle is equal to capital R. The radius of this circle is equal to 4, and the difference between the radiuses is capital R minus 4. That is to say AO equals to capital R minus 4. AO equals to capital R minus 4. So we actually implemented the Pythagoras theorem in the right green triangle, triangle AOS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AO, the square of the hypotenuse is AO square, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to OS square plus AS square. Again, according to equation number 1, OA square equals to OS square plus AS square. OA equals to R minus 4. OS square is R minus 4 square. OS equals to Y minus 4. OS square is Y minus 4 square. AS equals to 12 minus X. Therefore, AS square equals to 12 minus X square. We open the brackets on both sides of equation number 1, and we found out that R minus 4 square equals to R square plus 16 minus 8R, and it equals to Y minus 4 square. Y minus 4 square equals to Y square plus 16 minus 8Y. 12 minus X square equals to 144 plus X square minus 24X. We added 8R to this equation, equation number 1, and we got that R square equals to 8R minus 8Y plus 144 minus 24X plus X square plus Y square. We subtracted X square and Y square from this equation, equation number 1. And then we took a common factor 8 out of these two expressions. So here we got that this expression equals actually to 8 times R minus Y. So in conclusion, we found out that according to equation number 1, R square minus X square minus Y square equals to 8 times R minus Y plus 144 minus 24X. Then from point O, we draw perpendicular to BE. Here, from point O, we draw perpendicular to BE. We define the touching point between the perpendicular from point O to BE as T. So this angle equals 90 degrees and this angle equals to 90 degrees. You can see that quadrilateral OTME is a rectangle. Anyway, here we actually have 1, 2, 3. We have 1, 2, 3 right angles in quadrilateral OTME plus angle MOT plus this angle So 270 degrees plus the size of this angle, in total they must be equal to 360 degrees. We subtracted 270 degrees from this equation and we found out that angle MOT, this angle, is equal to 90 degrees. Therefore, quadrilateral OTME is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to OT. ME equals to OT. But according to our definition, ME equals to X. ME equals to OT. But according to our definition, ME equals to X. So from this equation, X equals to ME equals to OT, we will conclude that OT also equals to X. Likewise, the opposite sides of a rectangle are equal to each other. That is to say, MO equals to TE. MO equals to TE. But according to our definition, MO equals to Y. So from this equation, Y equals to MO equals to TE, we will conclude that TE also equals to Y. TE equals to Y. And what is the value of BT? BT equals to BE minus TE. Again, BT equals to BE minus TE. BE equals to 9 units. This is the radius of the circle. TE, we just right now found out that T equals to Y. So in conclusion, we found out that BT equals to 9 minus Y. So OT equals to X, BT equals to 9 minus Y. What is the value of line segment OB? Here O is the center of the biggest circle. B is the center of this circle that its radius is equal to 9 units. And the distance between those two circles that have an internal lunge between them at this point, they are touching each other at this point, the distance between their centers will be equal to the difference between the lengths of their radiuses. The length of the radius of the biggest circle equals to capital R. The length of this circle equals to 9 units. And the difference between the radiuses is capital R minus 9, that is to say OB equals to capital R minus 9. So we found out that OB equals to capital R minus 9. We implemented the Pythagoras theorem on the right triangle, triangle OBT. According to the Pythagoras theorem, in the right triangle OBT, the square of the hypotenuse is OB square and it equals to BT square plus OT square. OB square equals to BT square plus OT square. OB equals to R minus 1, so R minus 9, so OB square equals to R minus 9 square. BT equals to 9 minus Y, so BT square equals to 9 minus Y square. OT equals to X, so OT square equals to X square. In conclusion, we found out that R minus 9 square equals to 9 minus Y square plus X square. We open the brackets on both sides of equation number 2 and we got that R minus 9 square equals to R square plus 81 minus 18R. And here 9 minus Y square equals to 81 plus Y square minus 18Y plus X square. Here we added 18R to this equation number 2, and we got that R square equals to 18R minus 18Y plus X square plus Y square. Here we took out a common factor of 18 out of those two expressions, and we got that R square equals to 18 times R minus Y, and we subtracted also X square and Y square from this equation. So in conclusion, we got that R square minus X square minus Y square equals to 18 times R minus Y. So here we, from point C, we draw perpendicular to BE. But before that, we have quadrilateral SPME. Quadrilateral SPME. This quadrilateral SPME is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to SP. ME equals to SP. But ME equals to X. So from this equation, we will derive that SP also equals to X. In quadrilateral QCEP, quadrilateral, here from point C, we draw perpendicular to BE. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. So in quadrilateral QCEF, we have 1, 2, 3 right angles, and the sum of 3 right angles is equal to 270 degrees. 270 degrees plus the size of the 4 angle that is actually angle QCF. In total, the sum of those 4 angles must be equal to 360 degrees. So here we subtracted 270 degrees from this equation, and we found out that angle QCF equals to 90 degrees. So this angle equals to 90 degrees. Therefore, in quadrilateral QCF, we have 4 right angles, and therefore quadrilateral QCF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to QE. CF equals to QE, but CF is the radius of the smallest circle that equals to 1 unit. From this equation, 1 equals to CF equals to QE, we will conclude that QE also equals to 1 unit. So we can write here that QE equals to 1 unit. Okay? Then we join points B and C together by a straight line. What is the length of BC? B is the center of this circle that its radius is equal to 9 units. C is the center of the smallest circle that its radius is equal to 1 unit. So those two circles have an external length between them, that is to say they are touching each other at this point. And any two circles that have an external length between them, the distance between their centers, that is to say BC, will be equal to the sum of the lengths of their radiuses. That is to say, it will be equal to the radius of this circle that is 9 units plus the radius of this circle that is 1 unit. 9 plus 1 is 10, so the length BC is 10 units. And what is the length QB? Here, so BC equals to 10 units. What is the length QB? Here you can see that QB, here QB or BQ is equal to BE minus QE. Again, BQ equals to BE minus QE. QB equals to BE minus QE. BE is the radius of this circle that equals to 9 units. We just right now found out that QE equals to 1 unit. So in conclusion, we found out that QB equals to 9 minus 1, that is 8. So QB equals to 8 units, BC equals to 10 units, and the missing side is QC. So we implement the Pythagoras theorem on this right triangle, triangle QBC. According to the Pythagoras theorem on triangle QBC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, the square of the hypotenuse is BC squared. It must be equal to QC squared plus BQ squared. BC equals to 10, so BC squared is 10 squared, 10 squared is 100, equals to QC squared. QC is the missing variable, so we will leave it as it is, plus BQ squared. BQ equals to 8, so BQ squared is 8 squared, 8 squared is 64. So in conclusion, we found out that 100 equals to QC squared plus 64. Here we subtracted 64 from this equation, and we got that 100 minus 64 is 36, so we got that QC squared equals to 36. We took a root out of this equation, and we found out that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units, and we have already found out that quadrilateral QECF is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, QC is equal to EF. Here, QC is equal to EF, but we just right now found out that QC equals to 6. So from this equation, 6 equals to QC equals to EF, we will conclude that EF also equals to 6 units. Here, EF equals to 6 units. And then we know that quadrilateral here from point C we drew perpendicular to OM, so this angle equals to 90 degrees and this angle equals to 90 degrees. We define the touching point between the perpendicular from point C to OM as U, and then actually U, quadrilateral UMCF is a rectangle because it has 1, 2, 3, 4 right angles. Therefore quadrilateral CUMF is a rectangle because it has 4 right angles. So in quadrilateral UCMF, we know that CF equals to UM, or MF equals to, here we know that actually MF equals to UC, MF in quadrilateral, in rectangle UCMF, MF equals to UC. Okay, MF equals to UC, but we have already found out that MF equals to X plus 6. MF equals to X plus 6. So from this equation, X plus 6 equals to MF equals to UC. We will conclude that UC also equals to X plus 6. So UC here equals to X plus 6. And we can also conclude that in rectangle UCF, UCFM, CF equals to UM. CF equals to UM. CF equals to UM according to the rule that the opposite sides of rectangle are equal to each other, but CF equals to 1 unit. It is the radius of the smallest circle. From this equation, 1 equals to CF equals to UM. We'll conclude that UM also equals to 1 unit. So here we can write down that UM equals to 1 unit. Okay. So what is the value of OU? Here OU equals to OM minus UM. Again, OM minus UM equals to UO. Again, UO or OU equals to OM minus UM, but OM equals to Y according to our definition. UM equals to 1. We just right now found out that UM equals to 1. So in conclusion, we found out that OU equals to Y minus 1. And we already found out that UC equals to X plus 6. And what is the value of OC? Here OC, O is the center of the biggest circle, that its radius is capital R. C is the center of the smallest circle, that its radius is equal to 1 unit. and the two circles have an internal notch between them at this point. That is to say, they are touching each other at this point. And whenever you have two circles that have an internal notch between them, then the distance between their centers will be equal to the difference between the lengths of their radiuses. That is to say, it will be equal to capital R minus 1. So OC equals to capital R minus 1. So we found all the sides of the right triangle, triangle OUC. I drew triangle OUC in a new page and implemented the Pythagoras theorem on the right triangle, triangle OUC. The green triangle is the right triangle OUC. We just right now found out that OU equals to y minus 1, OC, the hypotenuse, equals to r minus 1, and we already found out that UC equals to x plus 6. We implemented the Pythagoras theorem on the right green triangle, triangle OUC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to UC square plus OU square. OC square equals to OU square plus UC square. OC equals to r minus 1, so OC square is r minus 1 square. And it equals to UO square. UO equals to y minus 1, so U square will be equal to y minus 1 square plus UC square. UC equals to x plus 6, so UC square will be equal to x plus 6 square. And we open the brackets here, and we got that r minus 1 square equals to r square plus 1 minus 2r. That equals to y minus 1 square. Y minus 1 square equals to y square plus 1 minus 2y plus x plus 6 square. X plus 6 square equals to x square plus 36 minus 12x. We added 2r to this equation, equation number 3, and found out that r square equals to 2r minus 2y plus 36 plus 12x plus x square plus y square. So we took a common factor of 2 out of those two expressions, and we got that r square, and we also subtracted r square and y square from this equation, equation number 3, and we found out that r square minus x square minus y square equals to 2 times r minus y plus 36 plus 12x. This is equation number 3. Then we wrote down all the 3 equations in this paper. This is equation number 3, this is equation number 2, and this is equation number 3. Then we created equation number 4 that states that r square minus x square minus y square, according to equation number 1, must be equal to r square minus x square minus y square, according to equation number 2. So equation number 4 states that r square minus y square minus x square, according to equation number 1, that is actually equals to here it is 8 times r minus y plus 144 minus 24x, must be equal to r square minus x square minus y square, according to equation number 2, that is actually equals to 12 times r minus y. We open the brackets, actually we subtracted 8 times r minus y from this equation, equation number 4, and we found out that 144 minus 24x equals to 8 times r minus y. We divided this equation, equation number 4, by 10, and we got that r minus y equals to 144 minus 24x over 10. So this is the value of r minus y according to equation number 4. Then we created equation number 5 that states that r square minus x square minus y square, according to equation number 2, must be equal to r square minus x square minus y square, according to equation number 3. R square minus x square, according to equation r square minus x square minus y square, according to equation number 2, is 18 times r minus y, and it must be equal to r squared minus x squared minus y squared according to equation number 3. That is actually equal to 2 times r minus y plus 36 plus 12x. We subtracted 2 times r minus y from this equation number 5, and we got that 16 times r minus y equals to 36 plus 12x. Then we divided this equation number 5 by 16, and we got that r minus y equals to 36 plus 12x over 16. We divided both the numerator and the denominator of this on this side of equation number 5 by 4, and we got that r minus y equals to 36 over 4 is 9, plus 12x over 4 is 3x, and 16 over 4 is 4. So in conclusion, we got that according to equation number 5, r minus y equals to 9 plus 3x over 4, and according to equation number 4, r minus y equals to 72 minus 12x over 5. Then we created equation number 6. Equation number 6 states that r minus y according to equation number 4 must be equal to r minus y according to equation number 5. Okay? Then we cross multiply this equation number 6, and we got that 4 times 72 minus 12x equals to 5 times 9 plus 3x. We open the brackets on both sides of equation number 6, and we got that 4 times 72 is 188, 4 times minus 12x is minus 48x, 5 times 9 is 45, 5 times 3x is 15x. So in conclusion, we got that 288 minus 48x equals to 45 plus 15x. Here we subtracted 45 from this equation number 6. 288 minus 45 is 243, and 48x plus 15x is 63x. Here we divided this equation by 9, so 243 over 9 is 27, and 63 over 9 is 7. So in conclusion, we got that according to equation number 6, 7x equals to 27. We divided this equation by 7, and we got that x equals to 27 over 7 according to equation number 6. And we have already found out that according to equation number 5, r minus y equals to 9 plus 3x over 4. Here we put the value of x inside equation number 5, and we got that according to equation number 5, r minus y equals to 9 plus 3x, and x equals to 27 over 7. So it is 3 times 27 over 7 over 4. Then r minus y equals to 9 plus 3 times 27 is 81 over 7 over 4. Here we multiplied 9 by 7, and then we divided by 7 in order to have a common factor with 81 over 7. 9 times 7 is 63, so we got that 63 plus 81 over 7 over 4 equals to r minus y. 63 plus 81 is 144, and 7 times 4 is 28. So in conclusion, we got that according to equation number 5, r minus y equals to 144 over 28. We divided both the numerator and the denominator of this equation on this side of equation number 5 by 4, and we got that 144 over 4 is 36, and 28 over 4 is 7. So we found out in conclusion that r minus y according to equation number 5 equals to 36 over 7, and we already found out that according to equation number 6, x equals to 27 over 7. Then according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. But r squared minus y squared is equal to r plus y times r minus y according to the algebraic identity that states that a squared minus b squared equals to a plus b times a minus b. Okay, so this expression r squared minus y squared is r squared plus y times r squared minus y, and it will also subtract x squared, and it equals to 18 times r minus y. We added x squared to this equation number 2, and we found out that r squared, that r plus y times r minus y equals to x squared plus 18 times r minus y. Then we put the value of x inside x in equation number 2, and we put the value of r minus y, that is 36/7, inside this equation number 2. And we got that according to equation number 2, r plus y times r minus y, and r minus y is 36/7, plus x squared. X is 27/7, so x squared will be equal to 27/7 squared, plus 18 times r minus y. And r minus y is 36/7, so it is 18 times 36/7. Then we multiply the equation number 2 by 7, and we got that 36 r plus y times 36, so your 7 will get cancelled, equals to 27 times 27/7, because 1 7 will get cancelled. And here 18 times 36/7, 7 will get cancelled, and we left only with 18 times 36. Here we divided equation number 2 by 9, and here 36/9 is 4, so we have here 4 times r plus y. 27/9 is 3, so we have here 3 times 27/7, plus 18/9 is 2, so 2 times 36 is 72. So 3 times 27 is 81, so we have 4 times r plus y equals to 81/7. We multiplied 72 by 7, and then we divided it by 7 in order to have a common factor with this expression. So in conclusion, we got that 4 times r plus y equals to 81, plus 7 times 72 is 504, all divided by 7, and 81 plus 504 is 545. So in conclusion, we got that 4 times r plus y equals to 585, because 504 plus 81 is 585, so it is 4 times r plus y equals to 585/7. And so we divided this equation number 2 by 4, and we got that r plus y equals to 585 over 4 times 7 is 28. And according to equation number 5, we already found out that r minus y equals to 36/7. We multiplied both the numerator and the denominator by 4, and we got that 36 times 4 is 144, and 7 times 4 is 28. So in conclusion, we got that r plus y according to equation number 2 equals to 585/28, while r minus y according to equation number 5 equals to 144 plus 28. Here we added equation number 2 to equation number 5, and we got that r plus r is 2r, and y plus minus y is y minus y. Y minus y is 0. So we got that 2r equals to 585 plus 144 over 28. 585 plus 144 is 729. So in conclusion, we got that 2r equals to 729 over 28. We divided this equation by 2. 2r over 2 is r, so we found out that r, the radius of the biggest circle, equals to 729 over 56. Again, the radius of the biggest circle equals to either 729 over 56, or in terms of numbers, it equals to 13.018 units. I will repeat again, the radius of the biggest circle is equal to either 729 over 56 units, or we can represent it as also that the radius of the biggest circle is equal to 13.018 units. Okay? Thank you very much.